Okay, we want an elastic example. We're going to show all our steps. So I'm going to go to the test review. I mean practice test. Oh, is that elastic? The cue ball. Okay, but that's so one of them's at rest at first. Oh, that's really easy. Okay, you are claiming that you're ready for the test. We're going over momentum practice, like this should be the final stages of momentum problem solving skills. After you've done all the homework and practice, one-dimensional elastic collision, and the velocities are not zero to start. This is about as hard as it gets. Okay, so first of all, hopefully you spotted that these are, that's elastic, that's critical, because there's an extra equation you have to use, and I want the velocities of both. Now, I change these vectors, v1 and v2. They're usually x comma y, right? Vx comma vy for one object. They certainly could be a bunch of different velocities uh, for the objects, but there will not be these hints. Like here I'm telling you, here's the answers, here's possible answers, so it lets you eliminate them. I'm a little bit worried if you only did this practice test that you kind of you can't help but glance ahead to, okay, what are the possible answers, and I can kind of solve them back. On the test, whenever we take it, Friday was my plan, there will not be any choices. You just solve it, okay? And I don't know, I could accidentally come up with some difficult numbers. Okay, it's one dimensional, though. Excuse me. So we can just say right, or what do they say, east? Yep, it just says right and left. Right is plus, and left is minus. Okay, so there's two equations we have to do. Momentum has to be conserved in all of these questions, really. V1 final. Okay, I would go ahead and copy that down as it is. You're allowed to substitute. Okay, like M1, let's say the cue ball, I decide this is object number 1. And then my other ball, it's labeled 3. That's why the pool ball example is kind of bad, because you want object 1 and object 2, but I just start doing 3, 4, 5, because that's what the balls are labeled. Okay. Now that I have this, though, I could, as I'm plugging things in, I can calculate. And newtons are units are optional, but I'm showing you what I'm doing. I got +1 newtons to the right, and the 3 ball was moving left, so minus 0.5 newtons equals. Now I like to take the masses and put them in parentheses, because I would approximate a mass as a dot if I had to. And since I started doing units, I gotta pencil that in there. But you don't have to do units. So to do this fast and easy, mass 2 is 1 kilogram. Go ahead and write your equation down. If you're starting with that equation, if you're starting with that equation and you insist on plugging things in, you've got to plug in velocity for velocity. Because I actually want to know if you missubstituted, if that was the one mistake you made, I want to know where you made it. Okay. And if it's a kinetic, if it's elastic, kinetic energy is conserved, and I would pause my work right there, and I would say because it's elastic, we have, and I memorize these differently than I give you. I give you the relative velocity equation, which is v1 initial minus v2 initial, the relative velocity at the start equals negative v1 final minus v2 final. Whew. Takes some effort for me to remember that way. Okay. So v1 minus v2 initial is how much? Is it 3.5? Oh, good. All right. It's plus 4.5 meters per second, because I have to subtract and the 3 balls moving to the left at the start. Okay. And then I would say V2 final minus V1 final. I can distribute my -1 if I feel like it. Okay. So I rearrange this equation and I just say, whoops, I need kind of a break there. V2 final equals V1 final plus 4.5. And it's all in meters per second. And then all I'm going to do is substitute this for V2. Okay, and that's the whole game. That tells you what V1 final is. And then you get to solve it. Okay. You're bored with this already. I can kind of not tell whether students are bored or exhausted or both. Okay, so we'll solve it pretty fast. We've got 0.5 newtons. We know that it's all newtons now. Equals, let's see how well I can do this. We're going to have just a V1. So we're going to have 1.25 times V1 final. And then I've got to do 4.5 times 1, oh yeah, plus 4.5. And that's it. Did I miss any negative signs? I always have to double check. Paranoia. 0.5 on the left, 0.25 plus 1, and then 1 times 4.5. So that's pretty easy numbers. Good for the subtraction. Okay, so V1 final is going to be -4 divided by 1.25. I'm not going to trust my brain. Okay, -3.2 meters per second. Okay, that probably gives the choice away right away. Oh yeah, there's only one that has that. On the test, I have to see also V2 final correctly with the correct direction. But here, V2 final, you just take that, you add 4.5. So that's how I get plus 1.3. If it's 1.30, that would be counted right. That's fine. To have too few sig figs, if you just left off zeros, no problem. It would be wrong if I flipped their plus and minus. They have to, or if I forgot meters per second, you'd lose half a point. Half a point out of 3 or 4. Okay, they have to have units, they have to have direction. But since I did a little axis up there with plus to the right and minus to the left, okay, I have my directions. It's worth it yourself. It's worth it. Take 5 seconds and remind yourself. Okay, these are easy. The 2D ones are easy. If you say so. Okay. I'll cut that video then and